Back in July, I reviewed the AC200 solar portable power bank. The unit I received then was a pre-production unit, and as such, some things changed by the time it made it to production. But since I've already reviewed this unit in a very extensive and detailed way, in this video I will concentrate on the things that are different. But before that, let me summarize the specs and features and my test results from back in July. The Bluetti AC200 is a 1.7 kilowatt hour 2000 watt solar generator. It measures 17 inches by 12 inches by 16 inches and it weighs 51.6 pounds. The 120 volt AC plugs tested well on the scope, displaying almost a perfect sine wave even under full load. The DC 25 amp port put out a regulated 13.3 volts DC, and I saw a maximum of 26 amps. On the input side of things, the included AC power supply charged the unit at a rate of 403 watts. The solar input was able to support a max of 6 solar panels and up to 710 watts. The lithium-ion battery yielded 1.324 kilowatt hours, which represents an efficiency of 77%. The teardown part of my review revealed rapid prototyping materials in the casing and a lack of a metallic subframe capable of withstanding substantial impact. The battery is arranged in a 14S pouch pack, very reminiscent of an EV module. It has a pretty beefy BMS module built in, and it uses an XT90 connector to connect to the main board. So that was the pre-production unit. This now is the final product, redesigned and designated model AC200P. So the first test is going to be testing capacity. The idea behind this test is to find out exactly what is available to you from the AC socket and then compare that to the stated battery capacity to figure out the total efficiency. The load is a commonly used type of resistive heater set at about 950 watts. And there we go, 1800 watt hours, or about 90% efficiency. That's pretty amazing. Now, let's take this apart to see if there are any visible improvements and to see the new lithium iron phosphate battery pack inside this unit. These retail units are better put together, so it's a bit harder to take apart. Specifically, this trim right here. The rest of the unit, it's actually very easy to disassemble, which is a good thing if you ever need to repair one of these. All right, here we go. Man, this production version of this unit is improved massively. All the parts feel a lot better. This is injection molded like rubber handles. They're pretty good. Now they have these screws that go all the way across to the bottom, right? So it's sandwiched both the top and the bottom places. And the plates themselves, the pieces of plastic, these feel way heavier, much sturdier than the last ones. And even inside you can see the mold marks, right? That they were high precision machine. That's like the lines of a cutter right there on that mold. And then some of these parts are then polished, right? So they don't have the marks. Yeah, this is a lot better. Now on the inside, also, there's a lot of good stuff in here, starting with a lot of silicon wire. This is a good thing because this wire is usually rated at 200C. Yeah, there we go, 200C. That means 200 degrees Celsius before this this material starts burning or starts melting, right? And so that means these cables are capable of handling quite a bit of heat, and they won't just melt if this thing ever overheats and stuff. And they're using it everywhere. They're using XT90 connectors here, XT30 connectors here, XT60 connectors there, even the AC lines, right? These are 12 gauge silicon wires. I've never seen that inside of a one of these units, right? So they're using high quality stuff. Everything is nice and labeled. Yeah, this is miles ahead of what we had on the pre-production unit. Cooling seems a whole lot better. I don't remember of the pre-production version if it had this, but this is basically a thin piece of see-through plastic to create a tunnel. So you have two fans in here. One sucks air in, the other one pushes the air out, and this is a tunnel here that has two big heat sinks on the side, and that's how it cools all the MOSFETs. The MOSFETs are right there, right? And there's diodes, there's all kinds of different transistors in there. Here are the caps. So all this stuff basically gets cooled. All the things that need to be cooled, there are inductors and transformers and caps in there. Everything that gets hot, you want to put it inside of this, in this region, because that's where the air is going to be coming in. So this is a lot better design than the pre-production unit, and it's looking really, really good. Now the battery is down there. Let's go look at the battery. All right, now let's talk about the battery. This is the new lithium iron phosphate battery. It's a 16S. I don't know the P. I haven't figured out, but it's got what looks like 26 650 cells. And here's a peculiar thing. You know, I'm the crazy guy that a few years ago started using PCBs to make batteries, and everybody told me I was crazy, they wouldn't work, that it was too expensive. A bunch of criticism. Some were valid, but most of them were just people just did lack any imagination. Well, this battery has a bunch of PCBs on it. It does have like kind of traditional plastic, casing, or like holders, right? And then what looks like it's nickel spot welded into the cells, right? And then they come out, and then they have these sort of PCBs. This, I think, is to connect the bottom. There's two rows of these batteries. So the bottom module to the top module gets connected through these. And this is just a regular PCB board. And then this is spot welder in there. Yeah, it looks like maybe laser welded on here, right? But you see the PCB here? There you go. And then it's got another one over here. This is where all the balance leads, right? So that the BMS can have the information that it needs. There's two modules, so there's two of these. There are all those lines. Then this one also is to connect the bottom and then the top, and then it has a line here, so it's not connected. So the bottom here is taking the positive, right, to go to the BMS, and then the negative. So these are the two main terminals of this battery. And then, can we see the name of these batteries? Here are the thermistors for temperature sensing. 4,000 milliamp hours, 3.2. And of course, they're kind of nondescript. It doesn't have a brand, so we don't know what, it's probably some Chinese brand that they're using. But lithium iron phosphate, for those of you who don't know, it's a much safer, less reactive, longer lasting version of the lithium batteries, right? Now, the downsides to that is traditionally it's been less energy dense, and so it's heavier, a little bit heavier and bigger. And that is the case that we're seeing with this unit. It is about 300 watt hours bigger than the pre-production lithium cobalt oxide version that we saw of this. So it's a little bit heavier, right? And it's about 10 pounds heavier, but some of that could be contributed also to the plastic here. It's heavier than the pre-production version than we have, because it's a little bit beefier and stronger, right? And so a little bit of that, a little bit of the battery, then the unit ends up being about 10 pounds heavier. So that's the downside of that. But these typically are rated into the thousands, 3, 4, 5, 6,000 cycles, where the lithium cobalt oxide versions of these cells are less, into the 500, 1,000, and maybe 1,500, probably max, stretching it out. So there are all the benefits of these guys. They're also less reactive. These ones they never like burst into flames, even if you saw them in half and stuff. I've been presently at tests where we put stuff through those batteries, and they just kind of smoke, they sizzle and stuff, but they don't spew out flames and stuff like some of the other chemistries would do. And I think now also we're getting to where we're very, very close in energy density. So now lithium iron phosphate is getting there. There's still quite a bit of improvement that the chemistries are having, so that is pretty good news. I like this battery. It's nice. I want to take it more apart, but I think I'd have to take this whole board out. It's got some more screws in there, so I thought, nah, that's good enough. This is good enough to see it. This is a pretty amazing thing. I like it. It's using a bunch of PCB material. This is like fiberglass as a platform to build. I like that. I'm doing that. I think I'm going to steal some of these ideas for my own DIY projects, right? It's massive improvements all around in this unit, and I like it. The only thing is the lack of the some kind of aluminum or steel frame, sort of like some of the competitors have, because this is heavy. You're talking about 60 pounds, right? So if this ever fell off of the back of your truck or something, most likely will not survive. It's going to have massive structural damage, right? Because this is just plastic. But I don't know, maybe not. Maybe this is super tough. Maybe they did some tests, and I wish I could do some drop tests on these guys, but these are $1,800 or $2,000 thing. I don't feel like, just to prove a point if it's gonna break or not, it's probably gonna break, right? So yeah, this is the only thing that I don't like. As far as everything else, yeah, this unit is massively improved from the pre-production. I'm impressed by these guys. The use of high quality cables, connectors. They're using this white compound. I remember I'd figure out once what it was, and I bought a big old roll, and I was using it in some of my projects. But this is really good. The use of it, because then it prevents from connectors coming undone through rattle, right? So if you put, for those of you guys that are thinking about getting one of these and using it in sort of like your van or your RV or something like that, then this is what would prevent all the internal connectors from coming up loose, right? And they put it all where all these sensitive components are going to be at, so that with time they do not come apart. So this is very, very good. There we go. Now let's put it together. And hopefully I can put it together and it'll work. Actually, that is one of the other things. Is I think, aside from the frame, from this outside frame that I broke a couple of these clips and stuff, because now they're using two-sided tape. This unit, it's put together. It's serviceable. You can, it's got now these brass molded. They're molded into the thing here. The screws come in and out easily. Here are the ones that are for the bottom ones. They have these big screws for the batteries. And then they have these other long screws that's kind of sandwiched together. They all go in and came out really nice. And so, yeah, I'm sure this is going to be no problem taking one of these apart and then replacing a board, replacing the battery, replacing things that would break down, right? So A+, they get an A+ for serviceability on this unit. It's pretty good. Okay, let's put it back together. go. Wasn't too bad to put back together. There we go. Turns right back on. Let me just turn the AC thing on. Yeah, turns right on. Yeah, this thing, it was easy to put together. Apart from this outside trim, everything else was really easy. Hey, so thank you for watching this video. I hope you enjoy this review. I am going to be keeping this unit because it's pretty good. I like it. I'm gonna keep the pre-production unit, this one, and this brand new one in the box. I am going to be giving it away. All you have to do is hit that like button, comment, and share this video, and I will be picking a winner from the comment section. So once again, thank you for watching this video. Stay tuned because in the future I will show you how to quickly add, for about 50 bucks, add one of these scooter battery pack to your AC200. If you have one of these and this is not enough battery to support your needs, very easily for about 50 bucks you can add more battery, very affordably and hopefully very easy to do, right? And so stay tuned for that video. See you guys on the next one. Bye. The hell? I present you guys to the EP500, 5 kilowatt hour battery with a 2000 watt inverter.